Welcome to the second lecture in Module 5. In this lecture, we'll go over the Hypertext Transfer Protocol, in other words, HTTP, in more detail. Now, we've already seen that HTTP is the foundation of data communication on the web, and it involves this request-response cycle between a client and a server, in our case, a browser and a web server. Now, HTTP is an application layer protocol that's used to deliver resources in a distributed hypermedia information system. In other words, the Internet. The Internet is an example of a distributed hypermedia information system. Now, in a web application, this request initiates some activities that are handled on top of the middleware, and it typically involves returning some resources to the browser. Now, in order to build and really understand how web applications work, this is probably the most important protocol that you need to understand, HTTP. Now, let's look at the types of resources that can be returned as a part of the HTTP protocol. So this can involve hypertext that's marked up using hypertext markup language, which is HTML. It could include cascading style sheets, hypermedia, or scripts. And let's talk a little bit about each of these. So hypertext is just text that can be displayed on your computer, and again, it's usually marked up using HTML. Or it could be on some other display device. Nowadays, it's very typical for that text to be styled using cascading style sheets, or CSS, and we'll talk more about those in the next lecture. And it can contain references to other hypertext that the reader can click on and then visit. Usually, clicking a mouse, you could visit some other site, perhaps through this link or some other section of the same page that you're on. Now, hypermedia is just a logical extension of hypertext to include other things like graphics or audio, video. HTML5, we're going to talk more about that in the next lecture, has better support for hypermedia. And then, as I've already mentioned when I discussed hypertext, hyperlinks can be embedded within your hypertext. And this is really the important part of a web page, is that these links actually define the structure of the World Wide Web as a whole. And this is the structure, by the way, if you think about it, that Google is exploiting when it gives you, when you do a search and it gives you the relevance of various of the importance of various websites based on the relevance of these hyperlinks. It's come up with Google has an algorithm for computing how important links are. And if you think about it, that's led to a company that's worth billions of dollars. Just this structure of the web has done that. And then finally, there can be scripts that are returned. And scripts typically are JavaScript nowadays. And this is code that can be executed on the client side. So scripts are code that's returned from the server to the client and then executed on your browser. And when these were first being developed, this led to a lot of security exploits. So you have to be careful to understand how scripts work. And we'll talk more about the problem of security associated with executing scripts on the client side in the next module. Now let's talk about a little background on HTTP. It's an extremely lightweight and simple protocol, and that's probably the reason that it's been so successful. Simple things tend to survive in technology. And so initially with HTTP 0.9, and this was the first HTTP protocol, you could only issue GET requests. In other words, you could just ask for static resources that were on the server, and the server would return them. And the only thing that could be returned with version 0.9 of HTTP was just HTML. And so here's an example of a GET request. GET /welcome.html says from the root of the web server, find welcome.html. Get it is what the request is being made, and the server hopefully will return this HTML to you, and you'll render it in the browser is what should happen. Now, HTTP 1.0 followed soon thereafter, and it's just an extension. And in fact, we're going to talk about 1.1 next, also just an extension of the original HTTP protocol. And what 1.0 added were headers, request headers, so you could have additional methods, not just get, but you could also delete or post or do other things with that. And then 1.1 followed, and it was all about trying to make the web application more responsive. And so there was a faster response that was supported by having multiple transactions take place over a single persistent connection. There was faster response and bandwidth savings by adding cache support. So if somebody makes a GET request and they make the same one soon thereafter, that response can be cached, and the cached response can be returned to you. So these are some things that happened with HTTP 1.0. Faster response for dynamically generated content, and I'll just let you look through these. It was all about making the web application more responsive so that users could feel like they were working with a typical application. Previous versions of HTTP were slow, and you could really tell that you were operating over the internet with those. With the advent of HTTP 1.1, it was a lot better in terms of response, and so it really supported the development of Web 2.0 and Web 3.0 applications. Now, a little bit more about HTTP. It's always been a stateless protocol, and what does that mean? This means that the protocol does not require the server to retain information between client requests. And so this actually is a challenge. If you're trying to build an application and you don't know what the previous thing the user clicked on is, you don't have state, and sometimes it's hard to respond appropriately to that user. So what happens is that each request is executed independently without any knowledge of what took place previously. And as I've just mentioned, this made it very difficult to build responsive web applications, to create the interactivity that users expect to see. So a number of technologies were developed to address this. Cookies are one, sessions are another, and another thing you can do is you can store some state on the client side and then send it to the server through URL encoded parameters. And so these kind of workarounds to this statelessness of HTTP led to Web 2.0 and 3.0 applications that are much more responsive than the initial versions of web applications. Let's look at an HTTP session. An HTTP session works as follows. There's a client, and in our case, again, it's the browser, establishes a TCP connection to a particular port on a host server. And by default, this is port 80. Web servers are typically listening on port 80. So when you deploy a Rails application in the development environment, we're working locally on port 3000. But when you deploy it in a deployment environment, it tends to be that you have the server listening on port 80. And so then a request is initiated through HTTP. And by the way, there's another piece of the puzzle in here. Typically, there's a DNS server, a domain name server, that translates a URL such as www.unm.edu into a particular address, to a particular IP address. And that's where this protocol is going to, by default, look on port 80 at that particular IP address, and there'll be a request that's made. So the server's listening then on the server side and waiting for the client's request. And upon receiving the request, the server processes that request, and it sends back a response that includes a status line. So you've probably seen these. HTTP 1.1 means the version of HTTP that it's using, and 200 OK means I'm able to satisfy that request. Here's the response. So this is what's provided as a part of the HTTP response. There could be an error message, and sometimes you'll see these error messages. Let's take a look, though, at what an HTTP session typically looks like. If you go to your console and just type telnet and then some address and then port 80, so here I've selected www.unm.edu, you see that it translates that into an IP address, 129.24.168.10, and it connects to that on port 80. And then I've typed get \index.html. Now, index.html is by default the root of most web applications. If you type this and hit return, the server will get that request and respond to it by providing the HTML that's in index.html. So let's try that. So from your operating system console, type telnet www.unm.edu, specify port 80, and telnet assumes that you're using the HTTP protocol here, and when you hit return, it's connected. And so we're going to issue the GET request, the HTTP GET request, and we're going to ask for index.html, which is the typical root pays that's offered for any website. And if we hit return here, we'll see that all of the HTML associated with index.html at www.unm.edu is returned to us. So this completes the second lecture in Module 5.